but anyway. Alright, so nuclear power, which is non-renewable. Here's my map of usage around the world, and I guess what you should know is, bless you, or who contains uranium. I'm sorry, this is a map of who has uranium. What is it? And this definition may come up. It's a non-renewable resource that's found in rocks, bless you, and it is commonly known as uranium, but it's in the Earth's crust as tin, and that word, unfortunately, you have to know, tungsten, and I don't even know how to say it last.
And this tungsten, the W on the periodic table.
So uranium ore is very valuable, obviously, even though it's relatively cheap, like they were saying. It's something that is highly monitored, and you have to be very cautious with this mineral. This is something I added probably after teaching nuclear for several years regarding the whole process of uranium, okay? So we'll start with the mining of uranium. Obviously, you mine uranium underground. You don't have to know whether it's surface or subsurface, depending, but it's found in rocks, and it's the decaying of rocks.
We don't have this slide.
That's why I said I added it. So you can just add the steps. The process to make fuel is part of the process of obtaining uranium to make electricity. Using it in the reactor, so you mined it, you refined it, as Brian mentioned in his presentation. It's now ready to be used in the plant. Then you have to deal with waste. Big, big, big topic. Decommissioning of the reactor. When a reactor's lifespan gets to a specific, they actually give it a specific lifespan. I think it might be 10 years, where you have to rebuild the entire reactor core. And I'm going to show you what that looks like in a minute. I'm not sure about the time frame, but there's another picture of mining, power generation, reprocessing, disposal. I'll go back. Why nuclear power? Well, it is, its output of electricity is significantly high, as Brian mentioned. If you look at this graph, 1 pellet of uranium is equivalent to 1 ton of coal or 3 barrels of oil. They even use wood. A cord of wood is what they call it, or 17,000 cubic feet of natural gas. Yes, Chris. Well, no, it's naturally occurring. Its use is to get it and produce electrical energy. Guys, this is not 100% accurate, but because these facts change, we've actually have plants that are in decommissioning mode, but there's just a map of our nuclear power plants, and you see we in the East Coast have a lot. And about 19% of the total net energy in the US comes from nuclear power. This is more facts of geography. There's 33 countries use nuclear power to generate electricity. Yes?
I thought they had to be built near coasts and water. But how's they want to do it on campus?
Well, they need a body of water of some sort to produce water. So they can have a large lake. Now, they want them near like in Florida, yours are usually on islands, like bordering coastal lands, because you want it alone, really. I mean, I'm glad I'm a little far away from it.
Where's
Turkey Point. There's one literally in between Miami and Key Largo. So we have, Turkey Point is in your town. Put it that way. You have to know the top countries, okay, or top areas or whatever, because this will come up. France, I think really France #1 is enough. Produce electricity. So when I mentioned to you that if you understood the process of coal, everything was going to be pretty much a similar type of reaction. Except nuclear has its own little thing going on, which is fission. And what you have in front of you is obviously 1 page of combined transition, so look at the screen. You have to know this reaction step by step in order and understand everything about it. So in nuclear fission, a neutron hits U-235. I could show you an animation that my students made last year, which is awesome. And they were in regular environmental. She totally nailed it. When uranium-235 is hit by a neutron, what happens? Look at the picture and describe it for us. It splits in half. When it splits in half, what's produced? Massive amounts of energy and more neutrons. These neutrons then hit the split U-235 and produce what? More energy and more neutrons. Eventually, you're going to have all this massive amount of energy, and I call this my uncontrollable chain reaction. It just keeps going and going. I mean, this goes on and on practically forever, for years. So you have to control it, as they mentioned in their presentation, and I'm going to explain that in a minute. So this is just another diagram of fission, and then to the far right, what do you see? Control rods. Now, before I even move on, what do you think is going to control an uncontrollable? Well, what do you think the control rod's function is? Not you guys. That's
To cool.
not cool.
Stop.
Stop it how?
Absorb.
Absorb what?
The neutrons.
The neutrons. The control rods will be entered into the reaction at times to control the reaction by absorbing the neutrons. Yeah. So here is a nuclear reactor, okay? And this reactor will come up on the AP exam, and it will come up in parts, and you have to describe the parts. So the first part that we want to reference is called the containment structure. What's inside the containment structure? The reactor. What else? The control rods.
Pressurized.
Steam and the pressurized vessels. Okay, so we're gonna go now and look at each one of those parts. So the containment structure, or the containment building shell, which I think I mentioned the other day, could be the size of this room, of the thickness of the walls of this structure. That's why what Emily was saying, it takes years to build, because there's a lot of construction involved in trying to maintain this reaction or keep this reaction controlled. So there you have steel concrete walls, and they surround the reactor core. Now, in the reactor core, you've got fuel rods. In the fuel rods are tiny pellets of uranium. And they undergo fission, and then they release heat. So that's how we're going to get steam. Water is added, it's heated, and then steam is produced. Simultaneously, so you've got the fuel rods. What do you think the fuel rods are in this diagram? Bottom or top? By looking at the picture. Bottom. Why?
Because
They're heated. Okay, so if you see the word heat in the diagram, you're going to choose the bottom as the fuel rods. Because obviously I'm not going to be able to put a red and yellow diagram. The top is the control rods, and they are there to absorb neutrons and control the fission reaction. They're moved in and out of the reactor core when it's getting too hot, or believe it or not, they let it go to a specific, these are the tests they do. They let it go to a specific temperature, and this is how Chernobyl happened. They were trying to see how far they can go, and they went too far. There was a malfunction. You add water, the water turns into steam, the steam spins the turbine is attached to a generator, the generator sends electric current. And then the water is cooled, and, oh no, in addition, they add water to keep all of this cool so that the reactor core doesn't get too hot. So this is what happened in Japan when they had their earthquake. The reason they were afraid of the nuclear meltdown was because they lost the ability to bring the water into the plant because they lost power. So they didn't really have a backup plan. So keeps things from melting. water is heated in core and steam is produced, and you know the whole process. Bless you. So this is a picture of an actual nuclear power plant, and you're seeing the control rods going in specific areas of the fuel rods. So those are overheating, they set the control rods down, something of that nature. Some advantages, yes.